Can we derive the expression for escape velocity without using energy conservation? Well, it's a common question which I come across, and today I'm going to answer this question. But before that, please do like, share, subscribe my channel, and please support this video. Now let's start. So what is meant by escape velocity? Well, it is the minimum velocity which is required to be given to an object such that it escapes from the gravitational influence of any planet. And that is what is meant by escape velocity. So let's calculate this. So I defined escape velocity. Now let's see what is its expression using the method which I'm going to tell you, right? But first of all, let's see it using energy conservation, and then we'll see it according to my method, right? So not my method, it is actually using equations of motion. We will see that, okay? So this is the planet, suppose, and suppose it has a radius r, okay? Let's assume it. And suppose the particle is at the surface of this planet, and we are giving it an velocity like this anywhere. Of course, escape velocity is independent of the angle, right, at which it is thrown, right? So of course, suppose it escapes and it goes to infinity. Let's assume over here, right? At infinity we have that there is no gravitational influence of this planet, so that is why we are assuming at infinity, right? So here the potential energy will be 0, right? And here the potential energy is equal to negative gm, the mass of the planet, and this is the mass of that body divided by the value, that is the radius of this planet, right? And what will be its kinetic energy? Over here it will be half mv square, right? This is the escape velocity, right? And since it is the minimum required velocity, so at this point the kinetic energy must also be 0, correct? Right. So we get that k is equal to, I mean that the total energy is equal to half mv square minus gmm by r, right? Okay. At this point, and since there is no other force acting on this body, so of course the energy must be conserved, right? Hence it means that the total energy at infinity, this is at planet, this at infinity, is equal to 0, correct? Kinetic plus u is equal to 0, correct? Simple, 0 plus 0 is 0, right? Now by energy conservation, we have T at planet is equal to T at infinity, that is the mechanical energy at planet is equal to the mechanical energy at infinity. Hence we have half mve square minus gmm by r is equal to 0. Hence velocity, escape velocity is equal to 2gm by r, right? So it is independent of the mass of this body, and I mean this body, not this planet. It is dependent on the mass of the planet and the radius of that planet. And for Earth, I guess if you substitute the values, you get 11.2 kilometers per second, right? So that is the escape velocity from Earth, right? Now let's see it using equations of motion. Let's see it. So suppose this is the planet, and the body is at the surface, and it is thrown with a velocity v, and it reaches infinity, right? Okay. So what will be the escape velocity in this case? Well, we know the value. We are now going to apply equation of motion in this case. So of course this is the radius r, correct? Okay. So one more thing we have to do, we have to assume a arbitrary point over here, suppose at some distance x from the surface, and suppose it moves at some distance. Well, we will see that, okay? So what will be the gravitational force at this point? Well, it will be equal to a is equal to gm by, not force, the acceleration due to gravitation, due to gravity, divided by r plus x whole square, correct? Okay. Now we have to apply a formula. We know that acceleration is equal to dv by dt, correct? Correct. Which is equal to v dv by dx, correct? From the chain rule that dv by dt can be written as dv by dx dot dx by dt, which is equal to v dv by dx, right? Okay. So this is the expression for the acceleration, right over here. So how can I relate this acceleration and this acceleration? Because when the body is thrown from the surface, then in that case what is happening is that the only force which is acting on the body is due to acceleration due to gravitation, due to gravity, right? So that is why this is the only acceleration experienced by the body, right? Simple. Okay. So we get a dx is equal to v dv. Correct? Correct expression? Right. Okay. So we got this expression. Now let's substitute this value. Well, what is dx? Dx is this distance, maybe dx, right? This small distance, and its velocity in this range. So we get gm by r plus x whole square dx is equal to v dv. Correct? Okay. But notice one thing, that in this case there will be retardation, so that is why we have to put a negative sign over here also. Why? Because there is retardation. Okay. Now let's integrate this. Whole square dx is equal to, let's integrate this. When the particle is at a zero distance from surface, then the velocity was v escape, right? And when it is going to infinity, towards infinity, then velocity is approaching zero. We are assuming this, right? Simple. Okay. So we can remove this negative sign, bring it over here, and then we can change this limit from 0 to v. Correct? Understood? Okay. So now let's evaluate this expression, right? Okay. So we get over here, when we integrate this, well, gm is a constant. So we have 0 to infinity of the expression r plus x to the power negative 2 dx is equal to, this expression will be ve square by 2. Simple. Okay. Now when you integrate this expression, what you will get? You will get gm by r plus x and with a negative sign. Why? Because we have integration x to the power n dx is equal to x to the power n plus 1 by n plus 1. Correct? Simple. Okay. So this is the expression. So when you solve this, you will get this expression. Of course, you have to substitute the limits from 0 to infinity, right? And why a negative sign? Because again it will be negative 1 when you add it, right? So it is equal to ve square by 2. Correct? And when you substitute the values, you can change the limits like this, 0 to infinity to 0. So you get gm by r plus gm by infinity, means we have to do a limiting case in that case, but of course that limit is going to approach 0. So gm by r is equal to ve square by 2. Correct? So we get ve is equal to root 2 gm by r. Correct? Okay. And this is the expression for escape velocity. So we are getting the same expression from the energy conservation also, and from equation of motion also. But is there any mistake in this proof? Well, comment me and tell if you see any mistake in this proof, right? So till then, bye bye, take care, and all the best.